And last time I did this, I sprayed the audience. This time the nozzle is facing me. All right. What I'm about to show you will astound and amaze you. State of matter that doesn't normally exist in front of your very eyes. So this is liquid nitrogen. I'm sure many of you have seen it before. And what I'm going to show you today is solid nitrogen, which is a little bit more involved than liquid nitrogen. So liquid nitrogen is liquid at 77 Kelvin. That's about minus 200 degrees Celsius. And solid nitrogen forms at 63 degrees Kelvin, so about 10 degrees below that. So you'll see it in a moment here. It's starting to go. I think the reason it took so long on the first attempt was because we had so much material. I practiced with quite a bit less, but for viewing purposes, I think the more is better. So, how do you cool a liquid down is the question that we're addressing here. We're doing exactly the same thing that you're doing when you blow on a hot coffee or on a hot soup. But because our breath is at room temperature, we can't blow up on this and expect it to cool down. In fact, we'd be heating it up. So we're going to simulate blowing on it by just removing the gas above it. So the hot molecules are going to be pulled out in the gaseous phase, and the liquid itself is going to cool further and further. Can I get a hand just for a second? Anybody will do. Okay. Can I get you to hold this end? Don't worry, you don't need the gloves just yet. But if you want to use the gloves, I can give you them. So it doesn't have to touch the vial, I just need it to be somewhere over top of it. Okay. So this vacuum pump I stole from John Davis's lab in the Department of Physics. And with his permission, stolen with his permission. And his lab holds the Albertan record currently for lowest temperature. And they are capable of producing temperatures below 1 degree Kelvin. They can make it down to 300 microkelvin or 0.3 millikelvin. And they are studying properties of superfluid helium at those temperatures, which flows with no resistance. So I have a superconductor demo, but it's the actual liquid analogy is if you have a solid, so you can actually get super solid helium and super fluid helium, and they will flow through each other. So that's where I stole this from, and that's why we are able to do this today. So step 2, we just start pumping on this. You'll notice right now it's not boiling anymore. The vacuum flask has come to equilibrium and there aren't bubbles.
There's pressure.
I was pressurizing it by just holding it still. But when I turn the vacuum on, the pressure inside is going to lower, and when you lower the pressure, when you go up on top of a mountain, the boiling point goes down. So you'll see what happens. It's going to boil instantly. So, dramatic music, please. liquid at room temperature because it has hydrogen bonds, because the molecule itself is polar. But because nitrogen isn't polar, it's not liquid at room temperature. And to get it to be liquid, it needs to be cold enough that what's called the van der Waals forces attract the molecules together. And to make it a solid, it needs to be even colder than that. So right now, it's going through the last chaotic bursts of boiling before the solid will form. But unlike water, nitrogen ice will sink in the liquid. So there's going to be an interesting property going on. The ice actually forms at the top because it's coldest at the top. And the air that's coming out of the liquid itself pushes it up, even though the ice is more dense than the liquid. So if you have the chance and you can look closely, you can see there's convection currents inside there. You can come close now if you'd like. So this is nitrogen ice, and unless you work with liquid helium or you do an experiment like this, you may never have seen this before.
That's cool. So if we touch the outside, would it be freezing cold if they touch?
No, because there's a vacuum insulating it, yeah.
Oh, wow. Very cool. Wow.
So we'll let it grow for a little while until there's sufficient mass that when we stop the pump, that will sink.
I have a stupid question.
Go for it.
Which planets have nitrogen in solid form?
Nitrogen in solid form, that is a good question. It's not a stupid question.
Okay.
You know, I don't know. That was kind of neat.
You planned that.
Definitely, that was planned. So you can see the ice that is touching the liquid falls to the bottom.
It's like cotton candy.
It is kind of, yeah. You know, it's the kind of thing you could never touch because it would instantly melt and then evaporate in your hand. All right, we'll give it another inch, and then I'll pull the plug.
So I have another stupid question.
Go for it.
So you're creating a vacuum which allows the molecules of nitrogen to actually come closer together. So how come?
So what we're actually doing is the hottest molecules in there are in the gaseous phase, and by pumping them out, the total temperature in the system goes down, and that's what allows us to form the liquid. So we're not, the cold stuff stays in there, and the hot stuff gets pulled out. And that's called evaporative cooling. So this is why you sweat on a hot day, and it's the same thing that allows physicists to produce things like Bose-Einstein condensates, where they're letting the hottest molecules escape from a trap. And here we're taking the hottest molecules out. So I'll stop the pump now, and we'll just see what happens to the ice. So you can see all of the ice now is sinking down to the bottom. And that is my solid nitrogen demo. Can I go to... Just hold this for tipping over. I'm going to take this off, and we'll reuse that nitrogen to show you some other interesting things. And this is all the hands-on, close-up magic. It's funny, I was thinking about my history, because Joel has so many neat stories. And when I was very young, I was part of a magician's club, performers club
that makes sense.
that did tricks. And I stopped doing it because I outgrew magic, and I didn't like deceiving people in that way. And you got it there? Here, hold on to this as well. Perfect. I'm just going to put the cover over top of this, and this, and while you're still holding it up, take that off. Perfect. All right. So, gather around. The next demo that I would like to demonstrate is the superconductor demo. So, not many people have seen superconductors before. And so a superconductor is a material. This is the superconductor here. This is a ceramic, but you can have superconductors made out of metal and different types of ceramics like this. So mercury, which is liquid at room temperature, if you cool it down to liquid nitrogen temperatures, it will superconduct as well. And when something is superconducting, currents will flow inside of it with no resistance. So it's basically the modern equivalent of the perpetual motion machine. And those electrons will just keep going and going until the temperature rises to the point where it no longer superconducts, and then the classical resistance comes back and the electrons stop flowing. And one way to demonstrate this is by taking a magnet, which everybody knows is part of motors and generators, and when you move a magnet past a wire, current flows in the wire. So what we're going to be doing is moving the magnet close to the superconductor, and that will cause a current inside the superconductor to flow, and that current has what's called a back EMF. The magnetic field will come back out, and it'll be just like a mirror. So when this approaches here, it sees a magnetic image of itself, and it'll be the opposite pole, so they will repel, and the repulsion will cause it to levitate over the surface. So I'll just demonstrate. Here's the magician in me saying, there you go, not levitating, and I'll add my magic potion, which pours just like water. And the bubbles you see here are the nitrogen boiling because the ambient temperature is above its boiling point. Alright, so got my magnet. It stopped boiling, so it's pretty close to the temperature we need it to be. There you go. So it'll sit there happily until the temperature rises to the point where the superconductor. So right now in the superconductor, there's a little loop of current going zig, 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 around and around and pushing a magnetic field back out towards the magnet. And what's neat is you can rotate the magnet, and the current will respond immediately and cause the opposing magnetic field to push it up.
Can you make it higher based on, you can't make it higher, you need a bigger superconductor?
You can. Here we're balancing the gravitational force with the repulsion. So the lighter the magnet, the higher it will levitate off.
Oh.
And the higher quality the superconductor, the higher it will levitate off. So this is actually a superconductor that we can make in undergraduate labs. The 297 physics students make these by combining yttrium, barium, yttrium and copper oxide powders in the exact precise proportions. If it's not the right proportion, this won't happen. And they compress it using a 2-ton press and then bake it, and all the atoms shake into the right spots to cause the superconducting lattice. And you can just happily...
Do you have to layer all those components, or?
You have to, we use a mortar and pestle to mix them in thoroughly. Ah, my assistants have arrived. So this is Tori and Steven, they're my lab mates, and they are here to help me bring all this gear back. So I've got one more demo.
So magnetic levitation, the maglev trains, do they use superconductors or what?
Yes,
Yeah.
they do.
Cool.
So it's a very similar principle. They have superconducting. I don't know if, I think the superconductor is in the track and then the magnets are on the maglev, but I could be wrong about that. It might make sense to do it the other way because then you need fewer superconductors. The trouble is to keep the superconductors cold, you'd have to have a lot of liquid nitrogen on the train. So I don't know. There's some technical reasons you wouldn't want to have liquid nitrogen on the train. All right, so since we're talking about trains, we'll just go back to the old-time model. This is a steam engine, and it's a model that was designed to accept water and a candle, and then the steam would drive the piston. But because liquid nitrogen boils at room temperature, we can use that as the liquid. And before we can actually get it to work, though, we need to cool the tank down, because it's made out of brass, to the same temperature as the liquid nitrogen, so that it won't all boil off immediately. So you can see as I'm filling it, it's boiling out of the funnel.
That looks really cold.
I think it is. You can sweep really well with liquid nitrogen.
Oh,
so while that's cooling down, I'll show you another effect. So that's called the Meissner effect, where the magnet is levitating over the superconductor. There's another kind of levitation that's not as cool as that, called the Leidenfrost effect. When I pour liquid nitrogen onto my hand is hot enough that it instantly boils the liquid nitrogen and causes a little air cushion to form underneath it. So it actually hovers over top of my skin. Meanwhile, my skin is cooling down, so I don't want to keep it in one spot for too long, or else I will get frostbite, like some people have learned. But so that's called the lead and frost effect. So it basically becomes a little hovercraft. And you can sweep the floor with it, because it'll carry dust and everything. So if you've got enough and you just spray it on the floor, all the dust will get carried across the room.
Have you done that in your room?
Whenever we've got leftover stuff like this, we always have fun. But it, it doesn't eliminate the mess, it just pushes it all to a corner. All right, so there's frost on the outside of the tank now. It's getting pretty cold. Just let that funnel empty, and then we'll dump the rest in through the hole. And hopefully, it'll work on the first try this time.
Is this the one you need batteries for?
No, that's the quadcopter, and that's
okay.
we can do that afterwards. But the people that wanted to see it already left.
So it has a safety valve on it?
Yeah, it's got a little whistle. So yeah, that's open right now so that the liquid will go down this one and out the other one. But I'll have to close that to get the engine to run. Trouble here is that the liquid is boiling when it hits the glass. You can see it's all skirting around on the cart. Let's see if there's nothing there. Okay. There you go. So I can actually use my body heat to make it run faster.
Oh, neat. Sweet. That's fun.
But the tank doesn't last too long. So there we go. And while there's still a little bit left in here, I wanted to actually fly the quadcopter over top so that it would look like the mist will come out and it'll look like it's flying through a cloud of mist. So this is not really physics related. This is more of a toy that I found. It's called a quadcopter because it has 4 propellers. And it's really neat because the board on here is smart. It knows what level is. So if it's leaning too much to the left, it will power up these motors and level itself out. So it's actually auto-leveling. And you can control the speed of the motors to make it go forward or back or left or right, up and down. And the neat thing, this is what appeals to me as the physicist, is that these 2 motors are spinning the same direction. So clockwise, and these ones go, well actually these ones go clockwise, these ones go counterclockwise. So to turn counterclockwise, you spin the clockwise motors faster, and it conserves angular momentum and it'll shift. So you can actually, it's a really neat physical principle that this works on. But it needs level to start. Okay. And I'll do my best not to crash into anybody. Here, let me try that again. Alright.
Well, filter did that? You get it right?
It takes practice. It's not working as good as I thought it would.
You're gonna try to land it?
Okay, I'll try and land it on the top of the doer.
Oh.
Here, let's start it up there. So you can see, it wants to level itself. All right.
Very good.
Good enough. So those, and our superconductor is still going.
Wow.
So, do you have any questions? Those were good questions, Byron, right?
Thank you.
Here, there's enough left here. Watch this. I'll do
It's
it.
dirty over there.
All right.
Push that little.
I'll see if it can push that. Do you want to come
That'd be
around the
fine.
other side of the cart so you can see it?
It's like, I don't know what it is exactly, to be honest. Oh, yeah.
Yeah.
It's just never on your foot there.
I have a question. So, in the movie Goldeneye, a liquid nitrogen tank explodes and freezes Boris.
Yeah.
Is that?
It was a big volume
Would
of
that
liquid
happen?
nitrogen, but I don't think that he would be frozen instantly like that. If you've got like a flower or something, I can refill this and we can show you how long it takes to actually freeze something and then smash it. But that's pretty messy, and I didn't bring a roast, so.
But would it like make a heat cushion and repel it all?
Yeah, that's what I imagine would happen initially. So unless they continue dumping it on him for like 2 or 3 minutes, I think that because he was frozen solid and then he fell over and shattered, right?
No, he didn't shatter.
He did shatter. He
just
just
got
fell
stuck.
over. Yeah. Well, I think it would take longer than what they demonstrated in the movie. But you could eventually do that, and there's been episodes of the X-Files where they found a guy who was decapitated, and then there were just bits of him, and it turns out that someone dunked his head in the liquid nitrogen and then pushed him over, and his head shattered, but his body didn't. I think that was X-Files. Yeah.
Do you watch Mythbusters?
Yes. What did they do?
Well, I don't know if they did that, but I was just curious if that would be something to
Oh, they're
email
probably
or write them, or
yeah.
maybe they've already done it.
Freeze the
Do
pig's
the-
head,
exactly.
and then throw it
Oh,
down.
poor pigs.
Cool.
All right.
Thank you.
Great, thank you.